Today we're on Lesson 5 of Unit 12, covering pages 423 and 424. I'll be using several colored pens. You want to have your calculator and a highlighter. Independent events. When the occurrence of one event has no effect on the probability of another event happening, we say the events are independent. In our first exercise, we want to decide whether or not the following scenarios have independent events. I'm going to start with B first. I have a coin, and I didn't have a die, but I do have a six-sided cube that I made and numbered it 1 through 6. So if I flip the coin and roll the die, in this scenario, we have a person flips a coin and notes that it comes up heads. Then the person rolls a standard six-sided die and notes that it comes up with a number less than 3. Go. Is the probability that the number came up less than 3 independent of getting a head when flipping the coin? Well, yes. They have nothing to do with each other. The two events are independent. The coin's outcome has no effect on the outcome of the die. And vice versa, actually. Looking at A, a person pulls a red marble out of a bag that has 5 blue and 7 red. Okay, I don't have marbles, but I do have 5 blue pencils and 7 red. If I pull a red marble out, let's say pencil out, do not replace it, then the probability of the next pencil being red, is that different than the first being red? So then a person pulls out another red marble. Is the probability of pulling the second red marble out independent of pulling the first red? Well, pulling the first red, that was 7 out of 12, but then pulling the second red, because that first red hasn't been replaced, has now been reduced to 6 out of 11. So is it independent? No, it is not. Once the first red is drawn and not replaced, the probability of drawing a second red marble has changed. Once the first red marble is drawn and not replaced, the probability of drawing the second red has changed from 7 out of 12 to 6 out of 11. We want to develop a tool for testing independence. In other words, our tool is going to be a formula. Exercise 2, we have the spinner below is spun once and its outcome is noted. Let E be the event of getting an even. So even. And the outcomes there, well, evens are 2, 4, 6, 8. And let P be the event of getting a prime numbers. 1 is not prime, 2 is, 3 is, 4 is not, 5 is, 6 is not, 7 is, 8 is not. And L be the event of getting a number less than 5. So L is less than 5, so that would be 4, 3, 2, 1. The probability of getting an even, well, there are 4 evens out of a total of 8 numbers, 4 eighths, which can reduce to 1/2. The probability of getting an even, given that the outcome was a prime number, so out of our prime numbers, which there are 4 of them, how many of them are even? Just 2 is even, so that's 1 out of 4. C, the probability of getting an even, given that the outcome was a number less than 5. Less than 5, there are 4 possible numbers less than 5, and of them, how many are even? The 4 and the 2, so 2 of them, which reduces to 1/2. The probability of less than 5 given even, so the even number of outcomes is our denominator. Even is 4, or 4 possible even outcomes, and the numerator is less than 5 and even. So of these even, how many are less than 5? Just 1. Oh, no, sorry. 2. 4 and 2. I'm looking at the wrong ones. I was looking at even. Oh, that was correct. Okay, and less than 5 would be the numbers 4 and 2. Okay, which reduces to 1/2. And the probability of prime given even, how many even are there? There are 4. And of those 4 even, how many are prime? Just the 2 is, so 1. Are A, or even and less than 5 independent events. Well, what we want to see is, does the probability of even given less than 5 equal the probability of even? The probability of even given less than 5 is up here, 1/2. And the probability of even is here, which is also 1/2. So yes. Are E and P independent events? So yes. Does the probability of even given prime equal the probability of even? Even given prime is 1/4. And probability of even was 1/2. No for G. So at the top here we have our definition of independent events. 2 events, A and B, are defined to be independent of another if the probability of A given B is equal to the probability of A, and likewise if the probability of B given A is equal to the probability of B. So you have to memorize this, and please write the words independent if the probability of A given B equals the probability of A. Memorize. Exercise 3, we have a survey of 57 sixth graders was done to determine which subject was their favorite. The results are shown in the table below, sorted by gender. So we have a total of 30 female, 27 male, for a total of 57. And favorite subject, we have math, English, social studies, and science. Our first question, does it appear, based on the data in this table, that the preference for math as a favorite subject is independent of students' gender? Okay, so if we're testing for independence, we say independent if. Independent if. And I can choose, we want math and students' gender. So if the probability of math given female, so I'm using M for math, F for female, is equal to the probability of math, or the probability of female given math as their favorite subject equals the probability of female, or the probability of male, so I'll use, well, male is not female. The probability of not female given math as their favorite subject equals the probability of not female, or the probability of math given not female equals the probability of female. So any one of these four we could use to test. And then once we do this, is the left-hand side equal to the right-hand side? If it is, then they are independent. If it's not, then they are not independent. Okay, so the probability of math as a favorite subject given female. So female is our denominator. The number of female is our denominator, which is 30. And of those 30 female, how many chose math as their favorite subject? 8. The probability of male, we have a total of, I'm sorry, this is math, sorry. Probability of math, this is 18 out of 57. Grab the calculator, 8 divided by 30. Is 0.26 repeating, and 18 divided by 57 is 0.315 something. Okay, so these are not equal, so no, they are not independent. Now, what if I tried this? What if I said, oh, independent if the probability of female given math as the favorite subject is equal to probability of female. Okay, female given math, favorite subject. So out of the ones, so math is the favorite subject, 18 is our denominator, and number of female is 8, so 8 out of 18. Does that equal the probability of female? Female's 30 out of 57. 8 divided by 18 is 0.4 repeating, and 30 divided by 57 is 0.526 something. Same thing here, no. So we see if the two sides are not equal, then they are not independent. But there's any one of these four ways that we could show that. B, does it appear based on the data in this table that the preference for social studies as a favorite subject? I'll use SS for social studies. Is independent of a student's gender. We'll say independent if the probability of social studies given female would have to equal the probability of social studies, or the probability of female given social studies equals the probability of female, or the probability of social studies given not female equals the probability of social studies, or the probability of not female given social studies equals the probability of not female. So we can use any one of these four to determine whether or not favorite subject is independent of student gender. I'm choosing this first one here. Probability of social studies given female. Of our 30 female, how many chose social studies as their favorite subject? 10. And the probability of social studies, 19 out of the total 57. I know that's 1/3, so that's 0.3 repeating. And 19 times 3 is 57. So 19 divided by 57 is 1/3. So in this case, yes, they are independent. And it would work if I went with this one. Let me try this one. Not female given social studies. So given social studies, 19 not female would be 9. Does that equal probability of not female? That's 27 over 57. So 9/19. Let's see, 27 divided by 57. If I math frac that, is 9/19. So they are equal. So if we tried this, the two sides would be equal. We would get different fractions that we have here, but whatever on the left would come out to equal whatever on the right. Exercise number 4 brings us to another formula for determining independence. But we are going to stop here for today, and we'll pick up with this in class tomorrow. Thank you all for your attention.